Okay, today's lesson 5.3. We're doing the quadratic formula, and we're not starting with the quadratic formula, though. This is a little bit of a review. So here's some stuff I've told you over time that would apply on this problem. Actually, you tell me. Tell me something I've said would be generally true about solving hard math problems that you could apply here. Yes, sir. If you can factor it, you should. That applies. Give me something else. How do I start this problem? Where do you start hard problems? On the inside. Very good. So we got to start on the inside. Don't worry about those absolute values. We start on the inside, where there is an x squared minus 6x minus 6, and that's where what you said, if you can factor it, you should, kicks in. Okay, everybody please do that, and you'll have a new equation. I'm going to use y because it's synonymous with f of x. And it factors nicely. Mr. Y, what does it factor to? You are correct, sir. You got it. Good. Okay. Next. Any other things I've told you that might kick in here? Yes? The x and y intercepts. Good. Okay, so tell me about those. What's their rule? The y-intercept is where x equals 0. Okay. The y-intercept is where x equals 0. If I put in a 0, let's try that. 0 goes here, 0 goes there. Just in your head, you don't have to write this all out. Just think about it. Doesn't that really mean negative 3 times 2 makes negative 6? And then to actually get it out of the absolute values, it becomes positive 6. So wouldn't you agree the y-intercept on this thing is 6? Cool. We know that, and that seems important. Boom. Okay. Somebody else, please raise your hand and state the other rule that we can use that's similar. Yes, ma'am. The x-intercepts are where y equals 0. Excellent. So put a 0 there. And then that's one of those top 20 skills to be able to solve one of those puppies. It's easy. There's just two little equations. So what are the two answers? 3 and negative 2. They seem important. Let's graph them. 3 and negative 2. All right, now some of you are probably scratching your head going, wait a minute, this is supposed to be a parabola. And it's looking like it's upside down. But don't forget, this is where the parabola would be. But we're doing the absolute value of the parabola. You remember how the absolute value on the outside makes the stuff on the bottom flip up? So this isn't going to be down here. It's going to be up there. Ring a bell? Okay, back to, let's just keep going on our process here. Where is the vertex on an equation? Okay, so you're saying that it has to be on a line that would run like this, halfway in between this and this. That's 2.5 in both directions. Does that make sense to you guys, that the vertex has to be on that dotted line? Okay, then we just figured out the x of the vertex. Do you get that the dotted line, that up and down line, that's an x line? Okay, the x of the vertex must be 2.5. It's 2.5 comma something. How on earth am I going to figure out the y? Yes, sir? Let's put it in the equation, exactly. You stick in 2.5. Because if I put in a 2.5 here and a 2.5 there, now all of a sudden, y is, oh yeah, it's not 2.5. I was thinking it was 2.5 from both ends. Thank you, it's 0.5. It is 0.5. Okay, sorry. I would have eventually got points and graphed them and been really dismayed about where they showed up. This should work much better. So 0.5 minus 3. A half minus 3, that's negative 2.5. And the other one's positive 2.5. So effectively, I'm having to do 2.5 times 2.5. A little bit of a pain. What if I say 5 over 2 times 5 over 2? That's the same as 2.5, isn't it? That's going to be 25 fourths. All right. So, moral of the story, my vertex is at 0.5 comma 25 fourths, also known as, let me see, let's simplify that a little bit. 5 times 4 would be 20, 6 times 4 would be 24, 6 and 1/4, right? All right, so I'll go up 6 and 1/4. This is 1, 2, 3, 4, 5, 6. So basically, it's just above that other y-intercept. And now my parabola goes up and through that and up and then makes parabola shape again. That was a tough one, but it involved a lot of review of really important, good math. Therefore, it was a good problem. Okay. What if I had wanted to cheat? XY table solves any graph. So I want to remind you of that because it really is true. You're on a test and you're going, I'm lost, I'm stuck. Not illegal. It's not illegal. I can take a number and stick it in there, and granted, things like a half are not going to be fun to put in there. And at least you'd start to get the idea once you graphed a few points, and you're like, oh yeah, it's going down like this, but then it's going up. Oh, that's right, it's an absolute value, and you might be able to start putting it together by just making points on an XY table. Like pick one, stick it in, see what you get. You get -2 times 3, which would be -6, make it +6, 1, comma 6. No, that was my bad. 0. 1, 2, 3, 4, 5, 6. Thank you. It just freaked me out because it didn't make sense to me that they'd have two of the same thing, but there is because it's a parabola. All right, anyway. So just keep on making points and you'd eventually find all the points on this graph. All right, that was a huge review of a lot of things, but not everything. Today's got a lot of review of higher algebra. When you were in, many of you were in honors higher algebra, and some of you were in regular higher algebra, and some of you were in FST last year. Anyway, they all come together into this class. You spent a lot of time on quadratics, and I'm in that unit here soon in this class this year with my kids in higher algebra. And you need to know, like, we basically took a month on it. So now here you are in honors pre-calc and reviewing it in like 2 days, a month worth of material. Okay, so if you feel a little lost, like it's going really fast, and you get home tonight and you're stuck on a few problems, don't be surprised. It covers a ton of stuff. You'll get it by the time we test on it. All right. Do you remember that this is called vertex form? Where that's the vertex? If you get it in this form, you're in a good spot because you have the vertex right away. But be careful. What's a mistake vertex you think people might use? -513. And you might say, well, isn't that what you just said the vertex was? No, I said the vertex was found here and here, but it's not -513. What is it? Ben? +5. Why? Can you explain why? Counterintuitive on the inside. You got it. Okay, so that means I have it in this form. I get my vertex instantly. It's 513. Okay, so there we go. I got my vertex. Is this going to be a U shape, like a valley shape, or a mountain shape? Mountain. Because of this negative here, it's a mountain shape. And that's going to go something like this. Now, exactly where does it touch? I don't know. How could I find it? One of those sayings would be handy right about now. The x-intercepts are... Yes, if you can factor it, you should. Can't factor that, though. Okay, so the x-intercepts are where? Y = 0. So I could set this thing equal to 0 and then solve it. I'll save you some time. The first thing you'd do is subtract 13. Then you would multiply by a negative. Then you take the square root of both sides, and you'd have... Anyway, long story. It'd be a pain in the neck, but you could do it. Okay, but what were we asked for? The vertex coordinate. I got it already, 5, 13. And then the domain and range. Can you do that from generally knowing what the thing looks like? Yeah. Everybody write down the domain and range for that parabola that I just sketched right there. And I'd like you to check with the person in rows 1 and 2 are going to compare. Rows 3 and 4 across from each other. And whenever I do that, you two always compare. Okay? And rows 5 and 6 compare with the person across from you. See if you got the same domain and range, please. I'll pause while you do that. Okay, so Domain, negative to positive infinity. I sometimes do this for domains like that. Does that make sense to you? Big R stands for what? All reals. Okay, good. The next thing, the range. From how low? Negative infinity. To how high? 13. Bracket on the 13. Easy place to lose a point. Okay. Because it touches 13. No asymptote there or anything. This is completing the square. It's another thing you learned last year. And it's like a 5-step process, but you're smarter than you were last year. And you already have it deep in your memory banks. So, between the two of those things, I bet you in 5 minutes, you'll be good at this. Okay, so to complete a square, this 4 doesn't really work nice. But if I want it, sorry, that's a 1. I don't know why I said 4. That's weird. But if I want to get rid of it, I know what I was doing. I was starting the process of doing what? Somebody smart figured out. I'm going to do what? I'm going to factor it? Nope, not going to factor it. I was going to move it over to the right. That's true, but there's something that you do. What's the very first step that's next? God, you can do this. Little German boy can help you. Half and square. Haven't you heard of him? Half and square. You take half and then you square it. Half of 8 is 4. 4 squared is 16. Half and square. Half and square. All right. So now I have plus 16 and minus 16. What the heck? Why did I do that? Some of you understand where I got that 16. I took half of the 8, which is 4, and then I squared it, and I got 16. But why on earth am I putting in that minus 16? That doesn't complete the square. I actually already completed the square right there. Yes? Yes. So bottom line is you can't just add 16 wherever you feel like it. To keep this thing balanced and equal to what it originally was, remember what it originally was x squared plus 8x plus 16. All I've done so far that was move the plus 1 over. Sorry, not plus 16. It was originally that, and I just moved the plus 1 over. You can move things over, right, in math. But you can't just throw in a plus 16 just because you feel like it. But you can if you balance out this equals equation here by subtracting 16. That's why you have to put both a plus 16 and a minus 16 so they balance each other out. Okay, now this part is the perfect square. Why? Because it factors. If you can factor it, you should. And I know for some of you that's going to bother you because you think you have to factor everything in if you do that. You don't. You can factor just this part and you just don't factor that part. It's legal to do that. It's just rare. Most times when you factor something, you want a number to come out of everything. But you can just factor part. Do you get this comes out to x plus 4 and x plus 4, which, oh, is that just a coincidence that it came out to the same thing? No, we did that on purpose. So that now it'll be x plus 4 quantity squared. Look, it's turning into vertex form. And then a number here, which is negative 15. And there we go. I have changed it into completing the square. I've changed it into a vertex form of the equation, and therefore the vertex is negative 4, not positive 4, comma negative 15. Okay, I need you to do a practice one of that. There's no way that everybody's already a rock star on this. You just saw it once. Let's go with 10x plus 3. Take y equals that. Move the 3 over to give you some room to work. Ask half and square for some help if you need to. And I'll pause for a second while you give that a try. Go. Okay. Hopefully you knew enough to move the 3 over. I'm going to ask for some people to tag team this problem. I'm going to start with you. Tell me what to do. Half of the 10. And half of the 10 is 5, and I'm squaring it, makes it 25. Yep, half one square. And then negative 25 to cancel it out. Excellent. And then this part right here factors, and now you should have y equals x plus 5 and x plus 5, and then this part goes together, and that makes negative 22. And then I can put it all together into one nice little x plus 5 squared minus 22. I have found vertex form, and therefore, Miss R, what's the vertex? Good. All right. Raise your hand if you've got the same thing as that. Okay, good. If you don't know how to do this, you need to learn it. And you're in honors pre-calc, so we need to step it up a notch and be able to handle it when it's a little more complicated, like trial 2. What's different about trial 2?
2x squared.
The 2x squared, the 2. So bring in one of those little sayings that I have that help. What? What? It's okay. What? I have many sayings. Not all of them apply at this moment. What's one of them? Half and square is not the one yet. That's coming. If you can factor it, you should. I can factor that first part, so I should. This 3, remember how I just said a second ago? You don't have to factor everything. So I'm moving the 3 over. And that also helps you to see that, oh, those two are separate. Oh, those two have a 2 in common. Factor the 2 out. And I'm close. Could I have taken out? Yeah, oh, yes, actually, this is one of those rare moments where you don't want to factor out everything that you could factor out. Otherwise, the thing won't be a quadratic anymore. See what I'm saying? Even though you're right, generally in factoring, we always try to take out as much as we can. In this case, we want to leave it to be a quadratic. Okay, who can finish the deal? Yes, sir. Now we half and square. Half of 6 is 3. 3 squared is 9. And then the 9 is 9. Bingo. All right. Factor it. But we could easily forget something really important. It's a very big but, so to speak. Come on, somebody catch this. Don't forget what? Yes? Why on earth would I times the 2 right here? Because those two 9s, the 9 and the negative 9, are supposed to cancel each other out. They're supposed to be of the same size. This 2 is going to get multiplied by that 9 there, making it effectively 18. Therefore, to keep it canceling out, we need to do that same multiply by 2 right there. I know, that's very easy to forget. But whatever you factored out here, you have to apply it right there to the other half and square number. All right, so final answer, 2. This part's x plus 3, x plus 3. This part's negative 18 plus the 3. Negative 18 plus 3 is negative 15. And then I'm pretty much done. 2x plus 3 quantity squared minus 15. I know the vertex. Do you? Okay. So when there's a number to be factored out on the front, if the lead coefficient, this is called, is not 0, if it wouldn't be 0 or you wouldn't have any x squared term. If it's not a 1, because most of them are going to be 1, then you have to be able to handle factoring out a lead coefficient like that. All right, man, we've covered a lot of stuff. But let me show you some problems. This is amazing. Unfortunately, we don't have time for it. I will be doing that derivation for you tomorrow. It is kind of cool to see where the quadratic formula comes from. All right, but I'm going to do that tomorrow. I do want to talk about some stuff that's buried in the quadratic formula that you may or may not know. There's 2 separate formulas within this formula. Okay, one of them is this part right here. And that part right there, all by itself, it can tell you how many solutions you will have. It's called the discriminant. You were tested on this last year, not to say you should recall it right this second. But b squared minus 4ac is important because it can tell you whether this whole answer will come out to 1 answer, 2 answers, or no answers at all. And if there's no answers at all, technically there are answers, they're just imaginary. All right. Okay, So, terrible things. All right, so here's the three things this could come out as. Do you agree that the only three options for this number is that it's positive or it's negative or it's zero? Okay. If it comes out to be a positive number, as in greater than zero, if b squared minus 4ac is bigger than zero, then you'll just have two normal answers, two solutions. Because that's pretty normal. Most of the time when you do the quadratic formula, you get a positive number underneath there, and you get two solutions. Okay, what if it's negative? I could write negative, or I could say less than zero. If b squared minus 4ac is less than zero, there are no real solutions, but there are what? Two imaginary solutions. I would accept no reals, because the reason I want to say that is because some of your multiple choice questions are going to ask you, are going to only give you the option of no real solutions. But I also want you to be smart enough to know that that does mean two imaginaries. It's no reals, but having no reals also implies you have something imaginary, and you'll always have two of them because it says plus and minus that number. And if it hadn't been a number at all, if it had been equal to zero, then that's the most special of all the cases. If this thing right here, b squared minus 4ac, comes out to zero, adding and subtracting zero do the exact same thing, don't they? So therefore, there's only one solution, and not only is it special because there's only one solution, but that solution, oh, who said it? Yes. Go say it again. Is the vertex. And let me show you why that's important. Okay, so I got my xy axis, I've got my parabola. If it's up here, there are no solutions. If it's down here, there's two solutions. But what if it just happens to kiss it ever so gently, right like that? It just touched perfectly. Then that spot is where you'd have an answer of zero in here, and that spot then is the vertex. One more thing. If this is truly equal to zero in here, do you get that it's like this whole part of the equation doesn't exist anymore? And the plus and minus becomes irrelevant because you're adding and subtracting zero, and I'm left with the other big equation. X equals negative b over 2a. That's a special equation you use to find the vertex. Now, didn't I just show you something a second ago that helps you find the vertex? Yes. I showed you complete the square. That finds the vertex. But so does this, negative b over 2a. It tells me the x of the vertex. Okay, so imagine for a moment, what I just explained was that. Okay, here's the discriminant list. I already gave that to you before, but let's just review it quick. What happens when the discriminant's less than zero? No reals, but that also means to imag. Okay, and how about if it's equal to zero? That's the special one. Then there's one solution, and it is the vertex. And the last one is, what if it's bigger than zero? That's kind of blah. It's two solutions, and I don't know what they are. I know nothing about them. They might be positive. They might be negative. One might be a positive. One might be a negative. All you know is there's two of them. Not nearly as neato as the other two things that can happen. All right. I'm moving on to, everybody catch up to me here, the homework. Now, actually, you know what? I want to stop for a moment and add a slide. I want to give you one. I want you to find the vertex for me in two ways. Here, I want you to complete the square. If you want to ask the little German boy for help, you're welcome to. And I want you to use x equals negative b over 2a to find the vertex that way. It's a formula, right? Negative b, negative 8, over 2a. A is 1, right? There's a 1 there. So it'll tell you the vertex very quickly and easily, too. Find the vertex both ways. If you don't understand, confer with the kid next to you when you get to the part where you're stuck. Because it should come out the same both ways, but I want you to see that both ways work. Because you might be asked on the test, find it with complete the square. You might be asked on the test, find it with negative b over 2a. This one stumps people sometimes because they're like, well, I've got one part of the answer. I've got the x, but how do I get the y? See if you can figure it out. It's not too tough. Do this by hand. Don't just think about it. I'll pause while you work on that. Okay, so we are recording again. I moved the 4 over because I'm completing the square. Now I'm going to do half and square. Half 8 is 4. 4 squared is 16, plus 16 and the minus 16. Then this part is now completely factorable, and if you can factor it, you should. So y equals x plus 4, and I could put another x plus 4, or I could just say squared. And then this part together makes negative 12. Raise your hand if you had that one right. Awesome. Next part. Negative b over 2a. Let's see if you like this better. Negative b is negative 8. Over 2 times a is just 2, which makes negative 4. What's that? That's taking this. This is the answer, right? It is negative 4 comma negative 12. That is the vertex. And I've already got the x of the vertex that fast. That is pretty fast. It's faster than complete square. But I now have to figure out the y. The y just doesn't jump out at me. But somebody can tell me this. It's not super hard. If x is negative 4, how do I figure out the y? You plug it in. You plug in the negative 4. You put a negative 4 in this equation. Now, I personally, once this thing is factored, I'd rather put it here, but that's cheating. That's using the other method. I should have to go back to the original and put in my negative 4. Okay, so I'm going to put my negative 4 in up here. Negative 4 squared is 16. And negative 4 times the 8 will be negative 32. Negative 32 in the positive 16 makes negative 16. And negative 16, oh wait, I erased my original number. It was a plus 4 there. Sorry. The original equation had a plus 4 right here. Negative 16 plus the 4 makes negative 12. And there I have it. So there's 2 ways to get the vertex. If this is like chicken or fish or beef versus the pasta, okay? Who likes complete the square better? Who likes this negative b over 2a better? Look at that. It's almost half and half. It's a free country. Do what you want. All right. So your homework for tonight. Within, we are going to be skipping some of the problems, doing some of the problems, of course. I'm going to have you skip number 1 because it feels a little too easy. Let's do number 3. And let's do number 6. And if I wanted to do this one, I would probably not want to complete the square. You see that nasty negative 3 in front? Try to factor that out, and you got a 4 as the next term. That's not going to factor real nice. Maybe negative b over 2a is better here. Okay? All right. So anyway, just a pro tip there. On to this one, we're going to skip. And this one, we are going to do number 23. Number 26 is a challenge, of course. Accept the challenge if you'd like, but it's not required. Moving on to the next page, I'd like you to do number 7 out of this equation. And number 9, by the way, how do you prove it has 2 real roots? Well, you can figure out what they are, or you can use the discriminant is the way. You remember the discriminant thing? That proves how many answers you're supposed to have. All right. So 7 and 9. On the next page, on the HL questions, I think I'm going to have you do 11A, and that's it. By the way, that root 18, and it says no calculator. How do you find a square root when you have no calculator? You know what? I'm going to call number 11A a challenge. Some of you might rise to this challenge. It's not super hard. This is like one of those prove you're smart. 11A is a challenge. But I'm officially challenging you. All right, that's all I have for you for today. This is not Friday. We're not doing a Friday quiz. Okay. Any other last questions? All right. So we have about 15 minutes-ish, a little less, more like 10. And I want you to work on your homework, and I'm going to ask you for scores on the last 2 assignments. You corrected 2 in a row, and so I'll ask for those scores in a second. Any last questions for the good of the order? That's all I have for the video.